Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad ZUFAYRI bin Muhammad Uzairi, and today we want to present about two subtopic in application of differentiation. So the first member is Muhammad SYARUL bin Adil, and the second member is Muhammad AKHMAL bin Muhammad Dahari, and the third member is Muhammad AMMAR bin Azaimuddin. The first subtopic is related rates, and the second topic is apply minimum and maximum problems. Application of differentiation.
What is differentiation? Differentiation is a method of finding the derivative or rate change of a function. The rate of change of the function is defined as dy over dx equal fx.
When do we apply differentiation? When finding the derivative or rate change of a function. When to determine value of maximum and minimum of particular function. Application of differentiation. First, related rates. Second, RELS and mean theorem. Third, analysis of function, increase, decrease, and concavity. Fourth, analysis of function, relative extrema, first and second derivative test. Fifth, apply maximum and minimum problems. First subtopic, related rates. Introduction. The idea is to find the rate of change of one quantity in terms of another quantity whose rates are known. The steps for solve. First, draw a diagram if possible. Second, label the quantities. Third, find an equation that relates the quantity whose rates of change is to be found the quantities. Fourth, use the chain rules, implicate the differentiate. Fifth, solve derivative that will give the unknown rates of change. Objectives. At the end, we will able to understand related rates of change problems involving geometry, formula, and functions. Solve the related rates problems using chain rule method and implicit method.
Problem statement for rate of change. The question: the volume of water in hemispherical bowl of radius 25 cm is given by V equals 2/3 pi times 48 x square minus x cube, where cm is the depth of the water. If the water is poured in at constant rate of 22 cm cube per second, at what rate is the level rising when the depth is 19 cm? Solution. Step 1. Draw a diagram and label the quantities. Step 2. Find formula. Given dV over dt is 22 cm cube per second. Find dx over dt when s equals 19. Step 3. Use the chain rule to differentiate. Dx over dt equals dv over dt times dx over dv. Step 4. Differentiate v. V equals 2/3 times pi times 48 x square minus x cube. dv over ds equals to pi times 192x minus 6x squared over 3. Step 5. Solve. Combine at the step 4. dx over dt equals to dv over dt times dx over dv. dx over dt equals to 22.3 over pi 192 times 19 minus x times 19 square. dx over dt equals to 0.014 cm per second. It will be the last answer. So, the conclusion, thus, if we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing.
Second subtopic, apply maximum and minimum problem. Introduction. The process of finding and solve maximum and minimum problems. The step for solve: 1. Draw a diagram is possible. 2. Find formula what to maximum and minimums. 3. Find value of when dy over dx equal 0. 4. Find d2y over dx2 and substitute x from step 3 to find y is maximum or minimums. Next, adjective. At the end, we will able to understand, apply maximum and minimum problem. Solve maximum and minimum problem by knowing to use the suitable formula from the geometry formula.
Problem statement for apply maximum and minimum problem. A closed cylinder container is to be constructed with a volume of 2,400 cm3. Find the dimension of the container with a radius r and height h, which will have a minimum surface area. Give your answer correct to 2 decimal places. So for the solution, step 1, we must draw a diagram. Step 2, we will find a formula. So the given volume is 2,400 cm3. So the volume of cylinder is pi r square h. H is equal to 2,400 divided by pi r square, and the area of cylinder we will get 2 pi r square plus 2 pi r h. So substitute h from the volume to area. So next we are simplify the equation. So area we will get 2 pi r square plus 4,800 divided by r. For the step 3, we must find value of r when derivative a divided by r is equal to 0. So first we must differentiate a. So we will get 4 pi r minus 4,800 divided by r square. From that equation, we must equal to 0. R we can get the answer is 7.26 cm. For the step 4, we will find h with a substitute r in a formula volume. H equal to 2,400 divided by pi r square. H we will get 14.49 cm. So the final answer is r equal to 7.26 cm and h we will get 14.49 cm. So the conclusion is Therefore, identifying the right formula and accomplishing the divide correctly will lead to find the radius and height, which will have a minimum surface area. That's all. Thank you.